As the great Zen master Lao Shang once said, do your math and Zen shall come. This is Miss Miller's Math Show with your co-host, Crystal.
Yeah, sing along, you guys. Okay. Do we want to do music again during our notes? What do you think? No? Okay. Alright, so the class has agreed to try and help jumpstart me today because I'm having one of those days. We all know what that's like. Okay, so here we go. Yesterday we learned the quadratic formula. Oops, I just realized this. Yay. That's good. Yes, I need your enthusiasm today. Okay, so yesterday we learned the quadratic formula. Today we're going to be looking at a piece of the quadratic formula in a little bit more depth. So you can see the quadratic formula up here. We're actually going to be looking at this piece of it today heavily. So that's the part that's underneath the radical. And that is, it actually has a name. It's called the discriminant. We don't like that. Are we discriminating against the discriminant? Yes. Okay, that's racist. Oh, God. Okay. There are no words. Okay, so here's what we're going to be using the discriminant for. We all know that the coefficient, or the letters A, B, and C represent numbers, the coefficients in front of x squared x, and then at the very end in a quadratic equation. So the discriminant tells us the nature of the solutions of a quadratic equation. So what does that mean? We have a few options here. Now, let me explain to you ahead of time. Everybody put your pencils down because this confused everybody last period. And I want to make sure you all understand what we're doing. This is our key term today. So I'm showing you where this comes from, why what we're doing is what it is, okay? The actual process that we're going to be using in our notes is a lot more straightforward, a lot less intense than what we're about to do. I'm just showing you where it comes from, okay? Did you all hear that? Clap if you just heard what I said. All right, so we have three different choices here. The first one is, let's do some color coding here. If b squared minus 4ac is, let's see, equal to 0, so what's underneath the radical could be equal to 0. That's one option. Another option is if what's under the radical is greater than 0 or positive, so b squared minus 4ac is greater than 0. And then the last option, what do we think? So first one is that what's underneath is 0. Second one is positive. Last one? What do we think? Negative. Good. Okay, so if b squared minus 4ac is less than 0 or negative, something will happen. Okay, so I'm going to give you three separate examples, and we're actually going to solve for the solutions to these examples, meaning solving for x using the quadratic formula, which is, again, different from what you're doing in your homework, but I want to show you where the homework stuff comes from. Okay, so here we go. The first example, 9x squared minus 6x plus 1 equals 0. Okay, so if we were to take these coefficients, A, B, and C, and we were actually asked to solve this using the quadratic formula. So let's actually go through and solve it. X equals negative b plus or minus. Again, you're not doing this on your homework. I'm just showing you where the very end result comes from. So we would do negative 6 plus or minus the square root of negative 6 squared minus 4 times 9 times 1 all over 2 times 9. So double negatives make a what? So it's 6 plus or minus the square root of, what's 6 squared? 36 minus, this comes out to 4 times 9 times 1, 36 again. And, yeah, negative 36, 18. What's 36 minus 36? 0. So this just goes away. So we get 6 over 18, which reduces to, what? 1/3. Okay, so how many answers did we end up getting? X equals 1/3. So that's how many answers for X? Just 1. Okay, and we don't have any imaginary numbers. This is not an imaginary number, so if b squared minus 4ac equals 0, then you end up with one real solution. Okay, so again, to give you, let's fast forward to what you're going to be doing on your homework. You're going to be given equations like this and asked to determine the nature of the solutions. So you're just going to say it has one real solution or, whatever else, the next two. You're actually solving for them. All right, so next one, if b squared minus 4ac is greater than 0. So an example of that would be x squared plus 5x minus 3. X squared plus 5x minus 3 equals 0. Okay, so again, if we have our a, b, and c here, b, c, and we plug these into the quadratic formula, we get negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 3 all over 2 times 1. Okay, so then when we simplify, we get negative 5 plus or minus the square root of, what's 5 squared? 25. Negative 4 times 1 is, and negative 4 times negative 3 is 12 over 2. Okay, and then negative 5 plus or minus the square root of 37 over 2. Okay, here's what this means. This plus or minus means we actually can separate this. Okay, so our answer could be x equals negative 5 plus root 37 over 2, or x equals negative 5 minus root 37 over 2. So that means, so how many solutions did we get in this one? 2. And do we have any imaginary numbers in there? No. So we have 2 real solutions. So if b squared minus 4ac is greater than 0, then we have 2 real solutions. Okay, last one. So again, the thing that you're doing in your homework is plugging stuff into b squared minus 4ac and then telling me how many solutions you have and whether they're real or imaginary. Last one is 3x squared minus 2x plus 1. So this is where, let's plug all these in and see what happens. We have a, b, c. Okay, so plugging these into the quadratic formula, we get negative 2 plus or minus the square root of 2 squared minus 4 times 3 times 1. Sorry, I know that's kind of hard to see. 2 times 3. Okay, so we get 2 plus or minus the square root of, what's 2 squared? 4. 4 times 3 is 12, and 12 times 1 is 12, so 4 minus 12. So 2 plus or minus the square root of negative 8 over 6. Okay, now, what happens when we have negatives under the radical? What happens? Yeah, Aiden?
You use I.
You use I. Excellent. So this could be, and we have the plus or minus again. This could be 2 plus I root 8 over 6, or 2 minus I root 8 over 6. So that means, so how many do we have? How many solutions? 2, and are they both, do we have any imaginary numbers in there? We do now. So this is 2 imaginary solutions. Okay, so if b squared minus 4ac is less than 0, then we have 2 imaginary solutions. Okay, that's a lot of information on one paper. Okay, so let me zoom in a teeny bit. So let me pause there. Shuggy, question?
On the third one,
Yes.
the two metrics, a lot of answers, so 2
I. Because remember when you have a negative radical? So remember, like if we do, let me move this over for a second. If we have the square root of negative 16, That's the square root of negative 1 times the square root of positive 16. What's the square root of negative 1? I. And the square root of 16 is 4. So this is 4i. Same thing here. We have the square root of negative 8. So that negative comes out and turns into an I. Okay? Go ahead if you have another question. Okay, so if you're missing, so the question was, if we don't have, like in all three of these examples, we had A, B, and C all there. If we end up having something like 9x squared plus 1 equals 0, okay, well then we don't have a B term, so B is 0 when you plug it in. That's all. Sloan.
So is it the only way that you can get one real solution if the radicals cancel each other out?
Yes.
That's the only way you can get it?
Correct.
Okay.
Correct. Aiden.
I'm not sure where you get the blue number from the red problem. For the examples, like b squared minus 4ac equals 0, then how did you get 9x squared minus 6x plus 1?
Oh, I was just, those are specific examples that will fit this. Stay tuned. I think your question will be answered in a minute. Rebecca. Yes. Yes. The negative morphs into an I outside of the radical. Liz? Okay, because what ended up happening from here is we get 6 plus or minus 0 over 18. What's 6 plus 0? 6. And what's 6 minus 0? 6. So we just kind of leave it off. Like it cancels out. Shuggy?
Sorry, again on the third one.
Yeah.
Like for 8, would we just leave it as radical 8, or do you not want to?
No, you want to simplify. I just wanted to move on so you could see. Yeah. Okay, let's go to our homework. Okay. Or our problems that are like the homework. Okay, so here we go. Determine the nature of the solutions. Okay, x squared plus 5x minus 3 equals 0. So let me set one of these up for you, and then I'm going to ask for some volunteers. Okay, so A, B, C. Okay, so this is when it says determine the nature of the solutions, this is where we are using the discriminant, which is b squared minus 4ac. So b is 5. A is 1, C is negative 3. So when we actually go through and evaluate this, 5 squared is what? 25. And negative 4 times 1 is? Negative 4 times negative 3 is? Positive 12. So 25 plus 12 is what? 37. So now we have 3 options from before. Our answer could either be equal to 0, greater than 0, which means it's positive, or less than 0, which means it's negative. So where does 37 fall there? Is it equal to 0, greater than 0, or less than 0? It's greater than 0. It's greater than 0, which if we go back to what we outlined in the last thing, if b squared minus 4ac is greater than 0, then we have 2 real solutions. So that's what we would say is our answer, that this particular problem has 2 real solutions. Okay? Questions? Okay. So, Rebecca?
Okay, when you say the first one that's actually equal to 0, is it literally equal to 0? Like, is it 0?
The whole thing is equal to 0, yes. Okay, other questions? Okay, I'm putting these next 2 up here, and I'm going to pause this for a second, and I'm going to ask you guys to try these on your own, and then I'm going to ask for some contestants to come up. Okay? All right, everybody try these on your own. Ooh. With our contestant, Noelle. Noelle, come on up and show us how number 2 is done.
Yeah. Here we go. Yeah. Here we go. I'm talking about
pain in the butt. So what? So what? I'm talking about right. 'Cause that's my favorite class. It's a pain in the butt. So what?
Hey guys, clap if you agree
So
with the
what?
bells.
So, we even I'm just talking 1, 2, 3, because if
Okay.
you didn't have math,
Whoop, let's start that. Okay, next. So we have one real solution. All right, everybody give it up for Tyler. Tyler's coming up and showing us the last problem. Okay. Are you are?
the charges hitting fees on our cell phone bills, and even on our taxes, all we gotta do is put in a little practice from the plumbers to the teachers, and even the physicians, the doctors and the lawyers, and even the musicians counting down. Like 1, 2, 3, 4. We can hear it on the beat and even read it on the score. Some say a waste of time. What are they doing it for? So they ain't no end up beginning to sweeping up the floor. Shout out to Miss Miller and even Mr. D, Miss Barnett, and Mr. Humphreys from Algebra 2 to trigonometry. If it wasn't for math, then where would we be? Shout out to Miss Miller and even Mr. D, Miss Barnett, and Mr. Humphreys. Hi.
That's my favorite class. It's a pain
All right, everybody
in
give it
the
up for
butt.
Tyler.
So what?
Okay. Questions on this? Okay. Last topic. Last topic. Oh. Darn, I know.
It was over.
It was over. How do you really feel, Slim? Okay, here we go. So let's do a really, really quick, easy review of something. If I give you, let's see, x squared plus 7x plus 12 equals 0. This is a side note. Can somebody remind me how I would go about solving that? What would I do? Sloan.
Diamond.
Cool, give it up for Sloan.
Yeah!
Okay,
My memory
so everybody think of two numbers that multiply to 12 that also add up to 7. Alan.
3 and 4.
Everybody give it up for Alan.
Yay!
Okay, then what? So now we have the x's over those. What do I do with those? Two things. Okay, good. Sloan, what is it? X plus 3 times
X
plus 4 equals 0.
Oh, I was just gonna separate them.
Okay. Oh, okay, so then go ahead. What is it next? Separated.
X plus 3 equals 0.
Okay.
X plus 4 equals 0.
X plus 4 equals 0. And then how do we solve each of them, Tyler?
Subtract 3.
Okay.
4.
Good. And 4 from both sides. Everybody give it up for Tyler. So our two solutions to this are -3 and -4, correct? Okay. Now, this next problem is telling us that we have a quadratic equation that has -7 and 8 as the solutions, and we want to come up with the equation that goes with it. Okay, so we've spent a lot of time with the equation, and we want to find the solutions. Now we have the solutions, and we want to find the equation given the solutions. So, can somebody tell me where they think we might go with this? Tyler? Plug it in. In what way?
Plug it in because they're both equal x.
They both equal x. Excellent.
So you plug them both in.
Okay, so good, so good. Okay, so everybody give it up for Tyler. Everybody give it up for Tyler. Now, how many clap if you agree that the only way that we can end up with x equals -7 is if we have x plus 7 equals 0? Okay, good. That's only a few of us, but at least a few of us are paying attention. Okay.
Yeah!
How could I end up with +8? Vanessa. X minus 8. Give it up for Vanessa. Okay, good. Where do we go from here? So how many people would agree that the way that I can get these two separate equations is if I could start out like that? Is that true? And then Shuggy said we have to FOIL it out. Excellent. Everybody give it up for Shuggy. Okay, so when we FOIL it out, we get x squared minus 8x plus 7x minus 56 equals 0. And then if we combine these like terms, we get x squared minus x minus 56 equals 0, and that is the equation.
Why would you want to do that?
Okay,
Just
it's
work
just making sure that you understand. You may use this when you get up into more difficult levels of math. You might be given the solutions and need to find where they came from, or one possibility of where they came from.
Oh, okay.
Other questions? Do we want to do the next one, or are you guys feeling okay? You're feeling okay. Rebecca.
Okay, so, for, okay, you know how you did the one with the two meters? Can you, if you solve that, could you tell what its nature is?
If you wanted to. You don't have to, but...
How would you tell?
Well, the fact that they already give you the solutions are negative 7 and 8. You have 2 of them, and they're both real. Neither of them are imaginary. So, yeah. Other questions? Okay, everybody send us off. You guys did a good job in jump-starting me today.